This is a short video explaining the general definition of passing lane availability and applying it to a real game example. So we're going to watch a video of a goal scored in a game between Atletico Madrid and Valencia, which are teams in the top Spanish league in the game they played in April 2019. So this player has the ball, we'll call him the passer. He fends off a challenge and plays a good pass to this player, we'll call him the receiver, who dribbles and scores a good goal. So what passing lane availability allows us to do is quantify the risk associated with this pass by using a real world number. Here is the same goal that we just watched, but using tracking data of the players. So this is the passer, this is the receiver and the pass, and then we can see the shot and the goal. Here is the exact moment of the pass between the passer and the receiver, and we can see the players around them. We're going to zoom in and we're going to measure the passing availability for this exact pass. This is a zoom in of the pitch of the passer over here and the receiver, and we can see that there are three opponents very close to them. To make things simpler, we're going to focus on only one of the opponents. The passing lane has two parts. This middle part is bounded by the red and orange arcs between the passer and the receiver, as well as these two circles around the passer and the receiver. An opponent in the middle of P and R can intercept a pass between both of them, and the circles are there to represent the idea that players who are not in between the passer and the receiver but around them also apply pressure, so they affect how good the pass can be. In order to make this passing lane, we define a parameter gamma as represented by these equations. D is the Euclidean or straight line distance between P and R. C and T are constants that enable pass asymmetry, which represents the idea that opponents closer to the receiver have more time to react and try to intercept the pass. The only parameter we need to change in this system of equations is gamma. Starting from close to 0, we increase the value of gamma until the passing lane contains the nearest opponent, and that will be the value of the passing lane for this pass. So here is the passing lane at value very close to 0, increased very slightly until the passing lane intersects with the closest opponent, which in this case is this person, and the value of gamma at this point is the passing lane value for this pass. Here is the same frame again, and here are all the opponents nearby, and then we can define the passing lane value for each opponent. So for this opponent it's 0.32, for this opponent value of gamma is 0.36, and for this opponent the value of gamma is 1.00. So for this pass as a whole, the value of gamma will be the smallest value for all the opponents, which in this case it's 0.32.